And so that's one of the things actually I would like to have us just as a learning kind of process for today too, and looking at our own impacts. If we look out here now and see, there's basically not really, I don't see from this trail animal trails, I don't see people trails and social trails, and when we get back here, just having walked through once and walked through back, I'd like for us to take a look back on our tracks when we come back, because it's amazing how quickly you can actually start a social trail without even intentionally knowing it. The path in that so the monitoring plan was set up to analyze 11 different vegetation types, and those are those upland and the lowland communities. And so we took the map that was in the environmental report and we did some on-the-ground ground truthing to say that there's polygons that kind of classified those into those 11 categories. And then Anthony, using GIS, created a program that divided the property up into grid cells that are 50 meters by 50 meters, and then had the computer randomly select within those polygons a certain number of sample sites that represent that vegetation according to how much of that particular cover there is on the valley floor. And so there's a total of 37 vegetation plots that we've put in between last year and this year. Last year we did all tree canopies, and this year we're doing all the vegetation for ground cover and shrubs. And that's what we're about to go and look at. Carl's doing the valley floor living country.
So he's taking over.
It smells good.
Did you see the ones when it was right? Vicky and I are directors from West. We walked the vegetation. They were kind of like Bridalville living. Oh, what did
It's a little bit of a different program because it was only every other year and for a much smaller school population.
So we call it
shifting that.
tickle grass.
Oh, that's what, yeah, we call it tickle grass.
Okay, I like that.
Yeah, right.
Yeah,
it just has one.
Okay, we'll do it every year. Funding permitted.
Yeah, and it's just always so rad.
So yeah, that was...
Okay. Oh, yeah. Yes, please.
I
was just guessing.
No, that's great. No, that's what we were talking about this earlier this morning, and I hadn't opened a book yet to check. But Esme said she thought it was Stellaria longipes, and then we were thinking.
Oh, these look like cats.
I got a hold of this list. It's like, I feel like it's gold, but it's by common name and not just.
Oh, geez.
So what, mouse ears?
Yeah, and they always have more than one common name. I've got a book over here, and we'll just look it up and see.
Oh, I have my Weber's.
Yeah, do you have a Weber?
Yes.
I have the new Colorado Flora right over there.
That would be a great book to see if that's
We're thinking longipes. I didn't confirm.
What did you say, mouse ear? I bet you it's in
Well,
here.
see, this
is
says
such a great
Tulo.
book.
Well, does it have an index by
Color.
By Latin? Look first for Stellaria.
Yeah, I like the colored one.
It's also by color right
Yes.
White.
This is such a
I love that book. That's my favorite. The Audubon one has it by color too. It's yay.
Yeah, and structure, a little bit.
is a
But you know, if we, I'm sure. Excellent. So to start this next section, I want to introduce two new people to you. Amanda Kuenzi is our community science director and also a fabulous botanist. And Barry Ray of Ray Environmental has been part of our team on the Valley Floor Monitoring Plan, specifically wildlife and vegetation, and also doing the repeat photography photo points are kind of some of the expertises. And so he's going to join us today and for this sort of introduction, and then he'll duck off and he and I will go join the vegetation team that's working on our next plot as a part of this, and leave you in the good hands with Anthony and Amanda. So.
Yep. So I think what we're going to do is kind of, I'm going to give you guys a little overview of, what we're doing as far as our methods and why we decided to pick those and how we picked our spots, although Marcy kind of alluded to that already. And the questions of why are we actually monitoring out here? Like, what is the question that it's one of those weird things with science, like we usually go in, we have I want to know this or that or something. So you have these this thing you're going to test for. With baseline monitoring, what we're doing is we don't really have a set of questions. So we're developing a monitoring plan that we can then ask questions of later, So designing a plan that someone can come back 5, 10, 15, 20, 50 years from now, redo it and compare those data sets to see what has changed. And so change in our communities is what we're asking about. We're saying, what is it now? and how might we ask questions of those data sets to see how it's changed in the future. And so like we've said, some plants like water, some plants don't like water. Some plants are going to change if water is there, some plants are going to, go away if water is there. This was all grazed at one point, so we have another thing that's changed here. The grazers aren't here, except we have a nice herd of elk here now. But our cows aren't here anymore, so that constant grazing pressure is not here. Other things that have changed in this landscape over time, up valley, or down valley that is, a lot of mine tailings were dumped down there. And so that is now recovering and changing as we go forward in time. So we have plots or sites that are, they're just a few junkus there, and it's mostly bare, kind of gravelly ground. So how might that change over time? We don't know, but we're asking questions. We're setting up a method that will maybe see why. So as Marcy said, we were tasked to look at the 11 or so communities on the valley floor property. So we have everything from upland spruce fir to aspen spruce mix to palustrin forest, which is what we're classifying as this particular site. So palustrin is just another fancy term for wet or wetland. We have emergent wetlands. We have wetlands that are emergent that are actually not or moving away from being wetlands. We have dry grassy sites. We have dry grassy disturbed sites. We have sort of shrub, sagebrush community type sites. So there's a lot going on here in terms of community diversity.
Is the cottonwood native to the floor?
The cottonwood
Shell
is,
station?
Yep. So the cottonwoods have been here since this was ice receded through the valley here, and cottonwoods came up from lower elevations. So cottonwoods are native, and it's a native species. It's the narrowleaf cottonwood is a common name, Populus angustifolia. And so that's actually one thing that we'll see change over time as these disturbances are removed. So cottonwoods come back. Depending on your elk browsing, that is. So again, there's all these management decisions that have to be made for the valley floors, and there's a lot.
And but some things we can't decide
exactly.
that are happening for us. There are some other changes probably you guys have seen on the valley floor. What are some other changes to vegetation or management or just change over time, kind of forces that are going on right now?
There were
Prairie dogs.
Yep.
Prairie dogs.
Prairie dogs are definitely, they may have been here historically, but they've certainly kind of come back and in a big way, and their population dynamics change radically from year to year.
Oxeye daisies.
Oxeye daisies.
Yeah, so our weedy species.
New plant communities coming in.
Thistles. Certain thistles.
Population shifting.
Oh yeah, we've actually got to experience the elk herd pretty closely yesterday. It was a lot of fun. They kind of ran by us as we were leaving yesterday.
Wetlands, the new wetlands that the beavers have created out of the Shell station. That wasn't there when the cows were here.
Yep.
Is that wetland across the river between Shandoka and the maintenance garage? Is that a natural wetland, or is that created by the channelization?
My guess is it's probably. I don't know. Are there beaver over there, Barry? You know,
I don't think so.
So that's probably created because not only on we have the berm that's the rail grade on this side. There's also a berm on the other side that was created when they dug that channel. So there's some impoundment of water there, and that's a great question too. So if we start changing the hydrology of the valley floor, if we decide that removing the San Miguel from the man-made channel back to its natural channel is a thing that we want to have done, then that means there's a lot of hydrologic and ecological changes that will occur because of that. So some of the wetlands that have been created by beaver will get flushed out. What's going to happen to the forest here? How will things change when we start making changes on the valley floor in ways that we think are positive, in ways that actually are positive? We're not dumping out mine tailings anymore. So that's a bad change, arguably. But that is always the crux of making restoration, ecology, or conservation biology decisions. Is there are trade-offs to any decision that we make, and anything that we try to do to improve might have a detrimental impact in other ways. So ecology gets really muddy.
Now, with the change in water table. How can you raise get the water up to a higher water table if it's at a lower water table?
That's a really good question.
Engineering. It can be done, but it'll take some engineering and money. That's the short answer. I don't know what the specifics they're looking at to potentially do that are, but it can be done. It just takes some ingenuity to do it. So, we have 37 plots on site. This happens to be one of them. And I will pass around some maps here that show kind of where all of our points are on the valley floor, easily contactable. So on site, we're looking at 3 different things, well, kind of 4 different things here. We're looking at our forest structure, if we have forest. We're looking at our shrub communities, if we have shrubs. And we're also looking at our 4 grass communities, so sort of 3 levels. The 4th thing that I kind of alluded to is we're also looking at willows in a separate way. So you've probably seen on the valley floor we have these communities of big clumpy willows. And a lot of them look like they're dying back, which they actually are. So their canopy is retreating. And so we developed a protocol to see what it is now. And then again, when we come back in 5, 10, however many years from now, see how those willows have changed. So 4 things. Forests, how forests are currently and how they might change. Shrub communities, forb and grass communities, and then our willow communities. And we're doing it all with a point and a couple of lines. And so this is always the fun part about science, is how do we quantify, how do we describe this in some relatable terms by using just a few points on the ground. It's really difficult. It's also really difficult when you're tasked to do a whole bunch of plots and you have a budget to work with. So there's all these little things you have to fine tune. I kind of like this, like the design. It's designing. It's like I have a background in naval architecture. Marcy has a background in fashion design. So, and we're ecologists now. So it's just, I always like teasing Marcy about that.
Yeah, exactly. Like my fashion sense here.
T-shirt and capri pants. It was
Mountain Studies T-shirt.
That's like a vintage Mountain Studies T-shirt too. We don't have any more of those.
Gonna do the tab benefit.
Mountain Studies Institute is based in Silverton and Durango. We have an office in both locations, and we do work from Telluride all the way over to Crete and Pagosa, working with San Juan mountain communities to do research and education. So doing things exactly like this. We have questions in our communities about our mountains and how to manage them sustainably. How can we use science as a tool through collaboration to help us formulate what those questions really are, and then get to the point of what do we want to know and need to know in order to make good decisions for our management choices. And so we do a lot of projects like this, and we collaborate with Telluride Institute on a bunch of things here related to water resources, which has been awesome to be able to join in the programs that you're leading like this. So thanks for the invitation.
And education.
Great. Yeah.
Thank you.
So Barry needs to go take off and go work. So I'm going to have Barry talk a little bit about what we designed for our forest monitoring protocol, and just give a little rundown of the forest health issues here and stuff.
So as Anthony talked about, this particular site is a Phalestrian forest shrub, and on this particular site there's not a lot of the shrub here is willow. And there's not a lot of it here, but on our other plots in this group, there's quite a bit. And as you alluded to with the water table changing, we're speculating that the willow is declining because the water table is dropping as a result of the channelization that happened in the river. And actually, the original channel to the San Miguel, and you guys might have talked about this already, went right through here. And so, looking at the age of the blue spruce in here, probably this blue spruce there were probably some here, but probably not at the level that there is now as the water table dropped, because blue spruce can withstand some wet, but they can't have their feet in the water all the time. So, and so it probably at some point this was occupied by willow, or it might have been occupied by juncus and sedges. So anyway, we did, I believe we had 14 forest plots across the valley floor, and we have 5 up on the hillsides, and the rest were down on the valley floor itself. And so what we did is from our plot center over there, and I don't know if you guys can, we have an orange stake over there which we GPS'd, so over time we'll be able to come back and resurvey this plot and see how things have changed, and you know, maybe 20 years from now, especially because of the proposed river restoration, there could be some dramatic changes that happen in here. And it could be that because the site is going to be a little, who knows what's going to happen and how they engineer the river channel, because now the water table has dropped and the river level has dropped as the channel has cut down into the riverbed. So if they have to find that same elevation, that means that the channel through here is going to be probably a lot lower than it originally was. But anyway, with our forestry plots is using some standard forestry measuring procedures. We use standard measurements. Anthony and I go back and forth.
I'm metric. Barry's old school.
Well, I'm a forester, and foresters, you guys have probably heard board feet per acre, but you're probably trying to envision cubic feet per hectare is a little hard.
Cubic meters.
Cubic meters. What did I say?
Cubic feet. Yeah.
Well, it's even harder to visualize.
It's funny because I as a scientist, we work in the metric system, and forestry is one of those kind of actually kind of like it in a way. It's this sort of like sort of old school holdout of like this sort of system that's been built up over years and years and years. And so if you go talk to foresters, you're talking about, you know, stems per acre or basal area in certain units that are you know, it's hard going back and forth while we're out there measuring in meters and centimeters and all that stuff.
But the beauty is, in the 21st century, we have computers, and all we have to do is, with a keystroke, is convert it.
Excel is great. You can just enter your data in there, it converts for you.
So we can live in both worlds at the same time. So anyway, from this, we determined, using kind of some standard forestry procedures, which trees were in or out of our plot. And those trees that were in our plot is we measured the diameter of the tree, we measured the height of the tree, we estimated the amount of percentage of crown that was occupied on the bole of the tree, and so because we didn't want to do it on plot because it can affect the tree itself, is we actually took an increment bore and measured growth and age on sample trees outside of the plot, and so I'm trying to think of, we also had a canopy closure measurement for the entire plot. And with that...
I have a question, Mary.
Oh, I'm sorry.
She had a question first, I think. Connie?
Oh, I was just wondering, I've never seen spruce grow in like clumps like this. You know, the so many main stems. Is that because when they cut the trees, the miners, or?
I'm sorry. Go ahead, finish.
No, I just wondered. I just never seen that.
Well, my theory, and I've been kind of looking at this, and I had to go into these trees, if you can see how thick the branches are,
and measuring the diameter.
And so my arms were a mess fighting all of these trees. But my thought was, in looking at this, is that, and I've seen it on some of the other plots, is that the spruce actually established on some mounds of declining willow, which you can't really see the willow now. In some places you can see, like over here, you can see old branches of willow that are kind of...
So if you think about this willow here, and it dying back as the water table drops, it actually provides a great nursery habitat for young spruce trees, an otherwise open area.
And also a little bit out of the water table. So it's my theory, and I can't say for sure if this is what happened, is the seedlings got established on that higher ground, and so you ended up with these clumps. with openings in between, because that represented where the willow might have been before they channelized the river.
Barry, how old are these trees, do you think?
The oldest ones were somewhere in the neighborhood of 70 to 80 years old. So, and that kind of goes back to, they channelized the river about a century ago, I guess, or maybe a little more.
1880s to 1900, I think, 1904 maybe.
So it's been channeled several times, I think. Because they rechanneled the river to build the Kids Hill for skiing. I can't even imagine that now, but it's, Senior Mahoney said that they just straightened it.
So, as an example, but somewhere, so if it was, say, 1880 to 1900 the first time it was channelized, and then these trees being 70 to 80 years old.
And that's 80 years old at another forestry metric is called diameter breast height, which is 4.5 feet off the ground.
1.38 meters if you're
And shortened to DBT if you're an acronym person. Anthony, and just want to make sure that everybody understands some of the terms, and it might seem like a simple one, especially to forest people and botanists, but canopy. Could just quickly, I don't know, just in case someone doesn't understand.
The canopy is if you look straight up. And this, we're kind of standing, because we stood in the sun, we're kind of standing in an open site, but if our plot is 20 meters square, and so we divided that into 4 quadrants. And if you look straight up, you'll see actually here the canopy's open, but if you look in the next quadrant over there, there's probably if you can envision looking straight down like we do on the aerial photograph, is this plot over here is probably 35 to 40% canopy. If you get over to the next quadrant, looking straight down, it's almost completely occupied by canopy. And so what we do is we kind of average those 4 together and come up.
And then we also use canopy cover to describe ground cover.
Exactly.
When doing vegetation monitoring. And I just realized that I should have brought my canopy densiometer, and that would be a fun activity. But do you have one of those mirrorized densiometers?
We actually did, and I think I have it in my pack, in my kind of kit of field gear. So I'll check and see if we have.
Because I'm Alessandra Berry. We haven't met before. Yeah. Nice to finally meet you. With my students up in Bridalveil, we every time I have a group up there, every year, we do exactly everything you described with the diameter at breast height, calculating tree height. He mentioned increment borer. That's a tree corer that you screw into the tree to calculate the age and look at different years, growth patterns, and when a tree grew a lot with a particularly moist year, or a skinny ring for a dry year. And one thing we continuously come up against is we have about 50 trees tagged that we do the diameter at breast height with, and we have some clumps. So how did you say you calculate for those clumps? Do you
measure every tree?
Every tree.
Okay.
And
then we have some that split here and become two. So at breast height you have 2 different trunks.
Yeah.
So do you tag them both? And keep tabs
the
on them
way foresters do it, and this
Science
relates
is
back
messy.
to lumber, is if it branches below that 4.5 foot mark, you count those as 2 trees.
Okay. Even though they're coming from the same.
Correct.
Yeah.
Right. Yeah, and if it branches above that, if you can get your diameter tape around it below the swell, is you count it as 1 tree.
Great, thanks.
And those are some
All
great
these gray areas in science, field
exactly.
science.
We'll do some practice here.
And there is,
your own turn.
and I will say with that, looking at what an individual is when we were talking about trees or shrubs or anything, it is very gray. So we're actually with our willows and our willow monitoring, we're kind of considering each clump of willows as one individual, if you will.
One entity, right?
Because going in and measuring every single little stem in there, it's just not a reality. That's not a reality. And there are definitely methods that have been established over the years and through just the scientific process that counter that. So we don't need to do that. We know from the literature that we can do this method and that works just fine.
What is the expected age of
spruce trees in general?
Well, blue spruce I don't think is a particularly long-lived tree, but I think they're probably like in the 200-year range. And again, that'll kind of vary. As blue spruce is an interesting species in that it really is. It's a wet site species, but more it's a cold site species, and so that's kind of one of the reasons why it's occupied the valley floor, and the other species like Douglas fir and Engelmann spruce are up on the slopes. And blue spruce can tolerate extremely cold temperatures, where other tree species have a hard time getting established. Once they're established, they can take off. But the Douglas fir on some of these hillsides are probably some of the older ones that are growing on drier sites may be approaching 300 plus years or more. And especially on this south-facing slope over here, which is outside of our area, is I'm sure there's some that are pushing 400 years.
I think there's some 300 plus on the ski area.
Is that right?
Sure.
Yeah.
Yeah, Engelmann and Doug fir.
There are no Engelmann spruce on the valley floor?
We really haven't seen. There might be an accidental.
Yeah.
Okay.
But for the most part, it's all of the evergreens that you're seeing out here, with the exception of a few Rocky Mountain juniper, are all blue spruce.
And are your plots round, square?
Our plots are both round and square.
Okay.
Our forestry plots are essentially round, and the vegetation, the herbaceous and the shrub plots are, well, actually the willow plots are round, and the herbaceous plots are square, or 20 square meters, which are divided into 10-meter quadrants.
One thing I wanted to point out with trees in age is size is not a good indicator of how old or young a tree is.
Absolutely.
We can have big blue spruce that are only 100 years old. We can have tiny, subalpine fir that are ancient. It's site dependent. More water you get, trees will they do. That's what they grow. Trees grow, and so if we have a blue spruce growing at a very productive site, it's going to be big. It might not be that old. Cottonwoods are actually a really good example of having really big trees but are very young.
Right. So there's some incredible dynamics going on within the forestry part of the valley floor and slopes. And like on the slopes, I'm sure you've noticed there's a lot of beetle activity, and that's taking out the Engelmann spruce. And I think there was a Doug fir beetle episode as well. So a lot of the Doug fir was taken out with that. And what we're seeing there is a conversion of a lot of that area to aspen, and that will create a cover under which the conifer will reestablish. Yeah, go ahead.
Now, do you have? Are you monitoring the alder because alder is one of the longer lasting wetland plants, and in Mountain Village there's a alder that's about 300 years.
Wow.
Yeah, 300 years old. Do you have a alder monitoring plan? Because I think there's a few
along the river.
There's a few in the area.
We are not doing that specifically, and we haven't done all of our plots. In fact, we've we've kind of started out doing the upland plots and hoping the mosquito population was going to recede as we move into the wetland areas. I'm not sure if that's actually going to happen, but so we really haven't gotten into all of our wetland plots yet, and but we aren't doing that specifically, and so I'm not sure what occurrence we're going to have for alder within our wetland plots, our riverine plots.
It's worth pointing out that these are very general plots, and we're just looking at what we have in terms of composition, community structure within these plots, and we can extrapolate some things out from that. We're not the only species that we're really, singling out are our willows. And that is because there are definite changes that we see, and the willows make up a good portion of the valley floor. You know, if we're not looking for rare plants. You know, if something rare happens to pop up in our site, great. We're not necessarily looking for weeds. If we have weedy species in our site, that'll be documented. If we have things like alder or other shrubby species that might be of concern, if they're there, they're there. And then it's for the deciders to take our information and then say, hey, we do want to then develop a monitoring protocol for whatever it is. Like, we want to just look at juncus. We want to go like monitor the heck out of juncus, and we and the royal we as in scientists can come back and design a plan around that. So,
and unfortunately, there's a tremendous amount of diversity on the valley floor. But as Anthony alluded to, is there's a budget, so there's only so many plots that we can do. And actually, with the cover types that we've delineated or identified out here, we could definitely break those down into
yeah, exactly,
cover types.
Do you have any other forestry
Not
points
really.
you want to make? Any other forestry questions for
Yeah,
Gary?
are you guys seeing any aspen regen that hasn't been munched? Because we did a tour 3 years ago, and every baby aspen that we looked at had been browsed.
And was that under a canopy?
Yeah, it was over on this side. Yeah.
Yeah, walking around last fall, we definitely saw a bunch that were mowed down, and there are some of our sort of emergent willow communities are definitely like, we actually were making note that we're just kind of like walking through a lawn of willows.
We've mostly talked about willows as being big and dying back, but there are actually lots of places on the valley floor where there's a ground cover almost of willows, because they are new and sprouting and they're tasty, and so they are all getting mowed to about like this high.
And with the aspen, it's a pretty natural occurrence because elk love aspen. It's just candy to them, and so they will move through and munch those. And really, because you have an aspen cover, it's not that critical to the integrity of that aspen stand. But what happens is, if some disturbance comes in and takes that overstory out, is the aspen comes up with a vengeance, and it's almost more than the elk can eat. And so they'll actually do a beneficial thing in most cases of thinning the aspen out. There are some places I know where it has been a problem where they can't reestablish aspen in areas where they cut aspen because the elk have just come in and sat down in that area and eaten everything.
Could you clarify for those who may not be aware of how aspen reproduce and the patches and genetics? And
right. Well, aspen is actually is considered a clonal species, even though it can flower and produce seed and reproduce that way. But primarily, it reproduces by coppice regeneration, which means it rises up from the root systems. And so after a fire, the root systems of the aspen are protected by the soil, and so that's kind of what comes up first. And even under the conifer stands, there are always little seedlings coming up, and they're always getting munched, but there's a canopy over it, and then eventually a fire comes along and takes that out, and all of that aspen takes over that site, and it converts to aspen. There's a really interesting place if you look along the hillside about halfway up the valley floor. There's one place where the aspen just makes a run up the hillside, and it's almost pure aspen with a little conifer coming in. And I speculate what happened there is when this was agricultural land, is they probably burned the fields, and that was an escape fire that went up the hillside. And if you look at it, there's just almost pure aspen stand with straight lines going up the hillside.
You can see that there, even just from this vantage point, there's like several patches of aspen on the south-facing slopes, which would be drier and likely more historic to burn over time than what you see in the same way when you look north. But you can definitely see a bunch of aspen, and so aspen is always a good clue to some disturbance that happened in the past. And they're usually fairly even aged with, so you can kind of tell time with those aspen groups by saying, okay, that's 100 years ago, or they're 50 years old, or something like that. So disturbances can be fires, they can be avalanches, it could also be a bug kill, like we're seeing a lot of beetles coming through now. 70 years from now, when the spruce beetle is through, we're going to have glorious falls, because that will all probably be aspen.
And another thing that's happening on this hillside that creates some clumps of aspen in the middle of the conifer is those slopes are, especially on the far end, are naturally unstable. So anytime you get a disturbance, you get these landslips, and aspen will often come in and occupy those sites. And so you'll see these just isolated patches in the conifer of the aspen, and that's probably what you're looking at.
I'm just going to ask, sorry, Dan.
That's all right.
Just because I have you here and I haven't had a good answer. So especially like up above town on like the Locals Weeby or the Judd Weeby, you know, up in that area, I noticed in particular, not as much this year, but last year, the black leaves on the aspen, like a whole aspen will be, especially the younger ones, will have. What is that? I mean, I didn't think it was sudden aspen decline.
It's probably not that, and I'd have to look at it to see. The aspen is, and I guess it probably is related to the fact that it's a clonal species. So you'll have large clumps that don't have much genetic variation. So it makes them very susceptible to a lot of different diseases.
Okay. So one thing, if you're walking through like an aspen stand, if you look up and you'll see actually little nodules of fungus. These little shelf funguses growing out of the aspen. You know, the aspen are, you know, a lot of bird species use them as their home. So a lot of pathogens are transferred, and once the clone gets infected, so sudden aspen decline, which is, you know, on a decline, thankfully. But as far as like the broad scale effects of it, aspen can be really affected by like pathogens, you know, fungus, any diseases, and as far as like the black stuff on, you know, or the tent caterpillars.
Are
bad.
Well, they turned. I didn't.
They wouldn't turn. Yeah, they just eat everything.
It's just I saw it last year, and then I just saw it in Rico this last weekend. Like,
and I'm not exactly sure what that is. I know that there's a pathogen called Cytospora, and if you've ever seen aspen that looks like it's got an oozing, rusty stuff going down the bark, and I don't know if it's doing that as well. But that's a real common one, and it's often associated with the aspen decline. And I think what it is the drought reduces its resistance to all of these pathogens that are affecting aspen.
Is the SAD primary, or is the which is primary, the rust or the SAD?
Well, I think the theory is that the drought actually just weakened the aspen to a point that all of these different diseases that are out there were able to express themselves in these aspen stands. And I know that Cytospora was one of the big ones.
SAD is not just one.
Right.
It's one thing. It's an array of
I just had a question about pests. Are you seeing much spruce bud worm in the valley floor? We're getting a lot of it just outside of the...
Not really, and they don't really... The spruce bud worm does not affect blue spruce the way it does Engelmann spruce. And it's very rare that I've seen that they really are affecting the blue spruce. Another thing about the reason that the Engelmann spruce has been affected so much is because of drought, and the natural protections that Engelmann spruce has is affected by drought, whereas blue spruce goes down in wet zones, so it goes back to pitch pressure, and when a beetle drills into the tree, the pressure of the pitch can actually push the beetle out of the tree.
And so one thing Barry said, it's colder here as well too.
Exactly.
So that's going to affect, you know, the insect populations here. So a budworm is not going to be, hey, it's freezing every morning, I don't really want to be here. Whereas up on the slope, it's, you know, Let's maybe just a couple more questions about forests. We have a lot of things to cover still today.
Forests are
Anything
fascinating.
else?
Yeah.
Down valley, on some of the blue spruce I've seen is like a white scale on the needles and such.
There's an aphid that gets on blue spruce, and I've never really seen it create a problem in a natural setting. I've seen it in urban settings, and so that white you're seeing, I think, is kind of like a web.
No, this is a hard.
Oh, it is?
Yeah, like if you scrape it.
Huh. I'd have to look at it to see
Okay.
exactly what that is.
Okay.
Does it look like it's creating a problem, or just kind
Yeah, I think so because the tips of some of the are dying, they're curled and brown.
And so there's some
blue or-
Blue.
Okay.
there are tip beetles that feed on the tastiest part of a tree
Yeah.
is that growing tip. So if you've evolved to eat that, there's a lot of goodies in that. So I know Anthony's trying to get rid of me here.
No, I want to keep Barry around.
Thank you.
Thank you.
Thanks a lot. Great.
Yeah, thank you guys.
And again, if you guys have other follow-up questions, regarding our forest systems, our protocols, just vegetation out here in general, please email myself or Marcy or Amanda. Or we're really easy to get to. It's our first name, Amanda, Anthony, or Marcy at mountainstudies.org, and we will try to field the question as best as possible.
And forestry stuff is my email is Ray RHEA at frontier.net.
And if you forget those, you can shoot your questions to us. And
There you go.
shoot them to them.
Okay.
Awesome.
Thanks.
Thank you guys.
It's great.
Questions?
Yeah.
You're totally done with this side then, yeah?
We are done.
Okay,
Done,
awesome.
done.
So we can trample this now. Let's break into kind of two groups. One group will come with me, and we'll talk about methods here on site and go through just kind of the process we did. Then one group will go with Amanda, and we'll do some plant IDing and look at some cool plants here. Not that we have a lot of diversity here, but Amanda brought some in from elsewhere. So
And then are we going to flip-flop?
then we'll flip-flop. So it is 10:10 right now. So if we want to be back by noon, we should be walking out of here by at least 1/4 till.
45 minutes each.
And so 45 minutes each. So we'll flip at 5 till.
Okay. Sounds great. So we have 45 minutes.
Yep.
Thank you. That is nice. Does anybody need more bug spray?
Oh, please.
Are they liking you?
We could this is one of our dominant species here on the valley floor. And so in this section, if going through our method, probably our dominant species, or at least understory species on this plot. So let's head to Plot Center, which is over here.
Not considered one of the European grasses out here. It's a rush.
No, this is super common. This grows, from here all the way up through, the Arctic. It's a circumboreal species, so it.
Oh, so that's good, huh?
Yeah, this is good. This is okay to be here. I think wiregrass is one of the common names for this. Although there's a lot of different wiregrasses out there that are actually real grasses.
So what is this?
This is a rush.
A rush.
A rush. So Juncus is the genus of it. So Juncus arcticus. Wiregrass is one of the common names for it. All right, so we're here, Plot Center. This is the center of our plot, and so we put these in, like I said, last year. Finding them is a lot of fun. We can get within a few meters with GPS, and then you're kind of like, oh, there it is.
Are you tagging any of
It's
the
even
trees?
more challenging when it's under an avalanche debris pile.
Yeah.
It was a couple years ago up in Bridal Veil.
So we're not tagging trees. What we're actually doing with our method is we have a distance in a cardinal direction to each of our trees. So whomever comes back finds this point, I go, 50 degrees or whatever that is right there, and I know that I've got, 1, 2, 3, 4, 5, however many little spruce that are in that clump. Not exact, but because you could be off with your declination of your compass a little bit, but it does give us a good idea of what the structure is. And so given the time and resources, we can actually model like, all right, I can actually do some mapping and say these are my distribution of trees on this plot, and we can extrapolate that out to the population here as far as looking at stand densities and things like that. There's a lot we could do on a plot. So what are our big questions that we're looking at? So we're looking at how might we've already talked about trees, so we're just looking at understory now. How might our understory communities change over time? In some cases, and I say understory, some cases our understory is actually our overstory if we're out in the grasslands where it's open. Our
only story.
It's our only story. It kind of is. Like we're not really getting that detail with our analysis of looking at. Because you can go and I've done plenty of this where you're looking at like a grassland, and you have lots of different canopy layers within like a half meter of stuff, and it is a pain in the butt to like just sit there and poking around because you don't want to disturb it. But So what we're doing on these plots, we're doing kind of two. We'll not talk about willows here, but we're kind of doing two things. We're looking at the frequency of species that we have, and we're looking at the relative cover of species that we have. So with frequency, and I think our frame's right here. If someone wants to hand me this guy. And this is just for our forbin grass and other low species. We capture a little shrub in this that gets counted. But we're looking at, let's see where my numbers are on this thing. I'm actually not really doing this. But we're looking at how many hits we have over a square meter. And there's two ways we can do this. And the way that we're doing this is we're looking at the intersections. So where these lines cross, looking straight down. And thankfully, when you have like things like rushes around, you have a nice little pointer. You can actually go in, and whatever those hits you have, that's what you have. So with this, type we have here is all going to be rush. So, and we're using a bunch of different we're using the USDA plant codes for our plants. So, Juncus arcticus translates into JUAR2. And so it's kind of funny when you hear like us out here on site and we're in GUR2 and Acme and POAR and things like that. So yeah.
So where they intersect,
correct.
Do you look at what's coming out of the ground right there, or what's laying over?
So this has already been trampled down because we've had people on site. Right. Ideally, what we try to do is you really want to have these on stands. Right there. Oh, okay. We, as in me, didn't quite have time to rig up stands for these before we got out here. I've had a lot going on the past couple of weeks. Ideally, you want it on stands and you look down, and whatever you hit with that point going down, that is your hit. And so you can have if we have the same species, it only gets count once. So if I'm, looking down and I just have a bunch of juncus here, that we only count one for juncus. But if I have multiple species, each of those gets a hit. So I might have juncus, Poa pratans is our main grass out here, and then maybe Trachyscum officinale, so dandelion, TAOF. And that's one of our kind of common things. And like I said, we're not really tracking where they reside within sort of the column of our plant community here, but we're gauging the frequency of our plants in the plot. So we have 100 points, so makes math nice and easy. The other way that we can use this plot, or this the frame here, is actually looking at this. These are what we call quadrats. So it's also gridded out into 100 quadrats. And so one of the things we could also do is look and see how many individual species we have per quadrat, or we could even do something more detailed, looking at how much percentage of each of those quadrats is covered by a species. But because we're doing a lot of these plots, limited budget, try to make it replicatable over time, we're using points. And you might say, hey, there's not 100 points there. We're actually using the edge, our two edges there. So.
I was wondering.
I mean, plus or minus a centimeter from that point, or right on the point?
It needs to be right on the point. So this is in sort of ecological sort of field method terminology, this is a point intercept. So we're looking at what intercepts that point. Another way we could do a point intercept is we run a transect, just like these, and you go a certain distance, and whatever your hits are at that point, and that's what you have. That's one of the common ways we actually do a lot of forest canopy measurements. If we're not using, say, a spherical densitometer or some other way of doing canopy, we go along and we have, you know, open tree, whatever. If we have a lot of different tree species, we document those.
So if this intersects all the way through, do you count that just once?
So, like I said, when with this plot here, it's already been trampled down.
Plastered down.
Like, our rushes are hard because it's hard to get like this kind of situated on them. So there is going to be some overlap.
Would you use a plumb bob or something if you did have a stand, or?
You know, if we were being super exact with it, perhaps. A lot of times with ecology, you want to make it quick, mobile.
Right. Thank you.
You know, some of the studies that we do, we set up a really fixed plot center. You might have a piece of equipment on like a tripod, and you want to make sure it's leveled out and everything. If we're doing like some really detailed forestry measurements, that's one way of doing it. I've used in the field actually a laser device. It actually has two lasers on it. One goes up, one goes down. There's a little circular level in it. You level it out, you push the button, and whatever that laser is shining on, those are your hits. That's way more accurate than obviously looking at with my eye, trying to point down with a piece of grass. But you know, I get my grass in the corner there, I push down, and then I get my hits. It's fairly accurate.
Yeah.
Again, these are, and so what we're doing with these, we have 4 of these per site. We have 1 in each cardinal direction. Again, trying to make this replicatable for whomever is going to be out here doing this in the future. We're setting our lower left corner of the frame at the 5 meter mark. So 5 meters out from plot center. So it'll always be on the clockwise direction, and we're moving in a clockwise fashion. Everything that we do is clockwise, just to simplify the methods for the next folks coming along.
Which side of the tape?
It's always going to be the clockwise, from going north first, the clockwise side.
So to the right.
To the right, to the right, to the right, and then to the right.
And it's 4 meter squares per quadrant.
Yep. What you might say, probably not enough. Which is actually, from a statistical standpoint, if we were doing a really detailed study, we would need to do more. But because we're doing a lot of plots within a given framework of time and money, we have to make it, you know, robust yet simple. So you have to pare it down a little bit. There's always trade-offs. So what we can do with the frequency here is we can actually quantify what our ground cover is like. So we can say, you know, we have a Juncus, Traxcum, and probably, if we're looking at this site, maybe moss-dominated site. And so we can pair that with the other information we're getting. And so maybe over time we come back, this might have type shifted over to, you know, grass. And that will show up in our frame. And ideally we do enough of these on the site that, you know, we capture enough of the diversity here within that. The other thing that we're doing as far as looking at forbs is we're looking at cover. And actually I'll pass around a couple of these so it's easier to see.
There's graminoids and there's forbs. And graminoids are grasses, which include this Juncus. What did you call it?
Arcticus.
Juncus arcticus, or any Juncus. It's a huge group of grasses. And then there's sedges, which are the really sharp ones. I'm sure we'll come across. I see some over there.
Yeah, there's some over here.
And then grasses, regular grasses. So here's a cute little poem. Do you know it?
You go ahead.
The sedges have edges.
Sedges have edges. Rushes are round, because you can twirl them in your finger and they're round. And grasses, like fill in the blank, have holes.
Or
grasses like asses have holes.
This is going to go viral.
Peggy Lyon taught me that. She's the botanist. So if it's okay for her, it's okay.
Well, if you're looking for another way of saying that, so
what's your poem?
So I have that one as well too. Yeah, I have a little bit cleaner version. Sedges have edges, rushes are round, grasses have nodes all the way to the ground.
Oh my gosh, I've not heard that one.
So if you look at a
Amanda, show us.
Yeah, Amanda will go through this. So,
Okay.
but if you look at our our sedges and our rushes, they're they don't like the this piece on a grass might have little nodes in there.
Okay.
Yeah.
Well,
So if you think of bamboo, if you think of bamboo, how bamboo is structured, those are nodes, and they have nodes all the way to them.
The whole version.
Get this on camera.
The whole version is referring to the fact that grasses are hollow.
Yeah.
Okay.
I also think about bamboo.
All right.
So there's a
We're
couple
not
of
talking about nodes as something growing out, but the sections of bamboo.
Yeah, exactly. Well, that intersection between the sections, those are the nodes.
And then forbs are the flowering leafy plants.
Flowering leafy plants, shrubs are more woody, and then another fun gray area is what distinguishes a forb from a shrub from a tree.
Yeah.
That is always 3 inches in diameter is what the official definition is. So 3 inches diameter at breast height differentiates a shrub from a tree. So I might have, if I'm looking at
oak brush can be a tree.
Yeah. So and things like gamble oak are maddening because they have shrub form, they have tree form. Our willows are the same way.
Alder,
And then seedlings and saplings.
alder,
And trees will,
alder can be 3 inches at breast height.
Exactly. So alder are both shrubs and they're both trees.
So that woody, like the potentilla, is very woody, but it's low.
It's low.
A flower. It's a forb.
We categorize that as a shrub.
Doesn't get 3.
No,
I've never
okay.
seen it
Yeah.
3 inches.
So there, I mean, in
Okay, so
Amanda
3
might
inches
talk
makes
about
it a
this,
tree.
but our nomenclature for plants is changing very rapidly, thanks to one William Weber and some other folks out there in the world. So actually, what we think of as Potentilla fruticosa is now not Potentilla anymore. It got changed to Pentaphyloides multiflorum. So the five leaf multiflower. And it is now actually something else. A genus starts with a D, and it's now Fruticosa again, as far as a specific name. So, if you guys are just getting into botany,
Wait
10 years. And I've been kind of on my high horse about this. Just because every time I come back, looking at new terminology, and I'm using these USDA plant codes, which are dated now compared to some Weberisms, the Weber renamings, and so like those usually don't match up, and the letters are wrong and all that kind of stuff. So it's, and I just kind of wish that all of taxonomists and phylogenists would just let's just wait like 10 years, get all the plant phylogeny and the genetics done. We'll know what everything is in 10 years, like how it all fits together genetically. And let's go ahead and like have a big renaming, and then we'll all relearn it and be grumpy about it for a few years, and then that'll be that. But it's just like this constant, like, I know these plants are these, or like all of a sudden these, and they go back to that, and then genuses get split, and families get lumped, and all this. It's,
just keep it a secret. Keep it to yourself.
Which it makes it interesting, but it also makes it a little frustrating at the same time, especially when we're trying to convey information, and And then sometimes it's like, well, let's just use the common name for now. Shrubby shingafoil works great because that's what it is. Even though there's a couple different species of it, but that's we kind of know what it is. So we talked about frequency. Let's talk about cover. We're looking at our ground cover. So what's covering the ground? Not looking at canopy, although we are using canopy, but not in the tree sense of canopy. We have a canopy cover for our rushes here. So the way we're looking at this is we're using a method called a releve. And releve is just French for related, how things are nested, related to each other. And there's also, we have our releve from ballet. And so there's a method of setting up a releve, which we didn't do. So I'm actually it's kind of a misnomer here as far as how I'm referring to this. But in terms of rough and dirty plant field ecology, looking at communities, this is there's the way we do a releve, and the way we would set one up is we start with 1 square meter, or you could even start smaller than that, and you count how many individual species you have within that site. You go out a certain increment. You assess how many more species do you have. You keep going and going and going until you have no more species, and that is your size, the area that you do your cover classes within. So your cover estimates within.
What do you mean by no more species?
So you go to a point where you hit no new species. So if we were looking at just this plot right here, I look down, I have my square meter down, I have 1 species. I go out maybe a half meter, another meter, I probably just have 1 species in there, although we do have some bryophytes in there. Some mosses in there. I go out again, and if I don't have any other hits, then that is... We say, because we're not worried about, with this size here, we're not worried about our overstory species. We'll talk about that here in a second.
How do you spell releve?
R-E-L-E-V-E, with an accent. Releve.
Releve, that's exactly.
So rather than doing that at every site, because that takes a while to do, and every site's going to be a little bit different, and we're trying to standardize sort of this into cover. For our forb and grass species, so our ground cover species, if you will, we're doing a 2 by 2 meter plot. Okay. And so that's just kind of, thinking about it, looking at some numbers and saying that probably is representative enough. And we're doing 4 of those, so we're actually doing 4 in each of our quadrants around our plot.
Circular.
Yep. Well, so it's like 2 square meters there, or 2 by 2 here, 2 by 2 here, 2 by 2 here, and then here. And again, just like with all of our plots, we're doing it.
5 meters?
No, we're doing it plot center.
Okay.
And it's one of those things that ideally you'd have things spread around the plots, and we'll maybe have a chance to talk about Daubenmeier here in a second. But trying to think about methods and workflow, because again, this is a job. We're getting paid to do this. How to be efficient with it too, and how to get as much information in the shortest amount of time possible. So we can actually have someone standing here at Plot Center doing the releve or doing the covers as we have a team working on our frequencies going around. So we can knock out one of these plots with a team of 3 or 4 in about an hour and a half. That's moving.
Are these transepts oriented in cardinal directions?
Yeah,
or?
sorry, I might have mentioned that.
No,
but
you did.
Did I? Okay.
You did? Okay, I missed it. I'm sorry.
So at each of our plot, each north, south, east, and then west.
Okay.
And that's every plot gets laid out in the same exact way. That way we can get back to, coming back 5 years, you might be off a little bit, but you'll be kind of in an approximate location of where you were before as far as laying these guys out.
Sorry, I just missed that.
Oh, no worries. And so with our cover, and I wish we had a little bit more diversity here, maybe we could walk somewhere where we actually have some more stuff going on. Let's maybe walk over here where we have kind of interface between some grasses and sedges.
You want your frame?
Oh, yeah, and this is...
So Anthony, for the releve, you do it right here in the plot center, and then you just move out on the 2 sides.
So,
because if you have 4 plots here, so basically you're using 4 meters in the center.
Correct, yep.
And then when you move out to seek more species, you just move out on this side and this
So we're
side
actually
on
not
each.
moving out anymore.
Oh, you're not moving out? You set it at 2.
We've set it at 2,
Okay.
yeah. So this is good. We have some Pulaski here. We have our
Some draba.
and we have some moss going on. So we can we have a couple different species we can look at. And so maybe let's just we'll pretend this is our 2 meters, although it's 1 meter, and ignore the pink lines. And this is always the fun part about not having a stand. So this is kind of how we lay, just try to keep things as upright as possible. Some stuff flops over. Hopefully it comes out in the math.
Just reapply. I just left them.
So, we're looking at a couple different things here. One thing we can do with this is look at, I didn't mention it, but we're looking at ground cover, what actually is on the ground in our frequency frames. So if I have a hit that is not vegetative, we actually mark that. So we're going to mark it as litter, bare ground, soil or rock, or other. And other has a broad category. We sometimes hit metal, we sometimes hit elk poop, we sometimes hit log, we sometimes hit old petrified cow poop. So
Concrete?
haven't hit concrete yet.
Yeah, that was always one of the stumbling blocks for some of our Bridal Living classroom students was, you know, how do we count that once you start doing your mathematical,
Right.
You know, like,
so
what if is anything a zero, or, you know?
Yeah. So the way that
Alessandra can speak to that.
and the way that we're doing the math on this is while we might have more than one hit for our actual ground cover or our vegetative cover per point, every point has one ground cover hit. It's going to be vegetative basil, vegetative canopy, litter, bare ground, rock, gravel, I think there's something like that language in there, or other. And so we actually get a real percentage. So like 99% of this is, in some sites, vegetative canopy. Some sites we have 99% sand or just bare ground. So that's how we're categorizing our ground cover. So we're actually not doing a ground cover estimate with our releves. But one thing I like to do with people, as far as just an activity, as far as your eye, is asking folks how much bare ground in this 1 square meter, in a rough percentage, like near as 5% or so, how much bare ground do you guys see? And think about it, don't call it out just yet.
Just in one of these?
Nope, in the whole 1 square meter.
Oh.
Yep,
Meter.
the whole 1 square meter. How much bare ground do you guys see in there?
Can I ask a question?
Sure.
Well, if you've got like one of these grasses folded over and it's covering what you would determine to be bare ground if you hadn't smashed it, does that work into our calculation, or?
That does not. That actually, well, in this case, so if I'm actually doing the frequency method, I know that it's folded over from elsewhere and I'm just going down. Even if it's there, I'm still going to give it a litter hit or something.
Okay.
If it, yeah.
Okay.
Just
So
at the folded over point.
at the folded over point. Now if it's
Does litter count as
litter, so we're just looking at bare ground. So we could look at litter.
no, and so you look under.
We're not looking under the litter. So if we have a spot that is like covered with litter,
That's litter.
that's litter.
It's not bare ground.
Now bare ground.
Oh, okay.
So, and actually, let's go ahead and for this exercise, just we don't actually have very much bare ground here.
Yeah.
Let's lump litter and bare ground into one category.
Oh.
Yeah. So, here we go. So what is non-vegetative cover? Like what on the ground here? What is not covered by vegetation?
Living vegetation.
Living vegetation, and moss is vegetation. So.
Now that makes it a little tougher.
Well, I see a sunflower seed, don't I?
Oh, that's funny.
That's litter.
Litter, yeah.
Literally.
I don't think I'll do sunflower seeds out here. Yeah. Who wants to? Who wants to venture? Who wants to share a number?
I will. My guess is 70%.
70% covered.
70% litter.
Litter.
On ground cover. As ground cover.
I was going
Anybody
to say
Oh.
80, but just to make it interesting.
I thought you were asking for bare ground.
Oh, sorry.
He combined it.
Well, what do you?
Yeah.
What
And
did
he
you,
changed his question.
What do you?
Yeah, he inverted his question.
Yeah, less than 10%.
Yeah,
for sure.
yeah.
Now,
If at all.
see here. Now, the bare ground 5%, and with litter I'd probably say 60%.
Well, we got a range of numbers.
Wow. And then the mosses count as
Mosses
mosses?
Are mosses.
Okay.
Yeah, mosses are mosses.
Now, what do you do if it landed over there, and we have a whole bunch of cut fungi over there? Now, where does fungi count?
That'll be its own vegetated cover.
Different line item.
Yep.
Now, would you just say unknown fungi?
What does your stick count as?
Stick is
litter.
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 Yeah.
Okay.
So for things we're not IDing bryophytes to anything besides bryophytes. So
That's moss.
and so that's going to be our mosses or some of our other sort of mossier type species. And we're just categorizing those as bryophytes. If I have a fungus in there, I'm probably going to do the same thing because those are things that those take a long time unless you really know them. And I am not a moss person at all. Like I can tell you it's sphagnum moss from like whatever this is, but that's about it. So the reason why I like to do this exercise is that estimating cover of any type, there's always going to be a wide range out there.
What's your estimate?
So my estimate is going to be probably, we actually have, if in the way that my mind works, I pull things together. And this is something you train yourself over time. So if I'm pulling all this litter together into one piece, we actually probably only have about 40% litter cover on this site. So it's easy to overestimate things or even underestimate things. Bare ground's one of the ones that people underestimate all the time. So if I had this spot where it was just bare ground, if you're looking at, say, a bunch of grass, little bits of dirt in between them, it's always an underestimate. And it takes a very long time in the field and doing this a lot to actually calibrate your eye. And you have to, and there's you actually you can get a bunch of templates. You can get these little printout pages and stuff of showing this is this percent, this is this percent, this is this percent. It just takes a lot of time and practice to train your eye to that. Same with forest canopy. I've done enough forest surveys just walking through just to kind of look up and, and actually it's one of those things that I was always kind of in the back of my mind, what is my canopy coverage in a given area as I'm walking through. So where we are right now, we have, probably 15% canopy coverage right here, just looking straight up. So,
Is that ever kind of correlated with airborne kind of data, infrared or LiDAR pulses, or?
Canopy that's getting better actually, and LiDAR is changing the world a lot. And
And define that?
Pressure the town of Telluride.
Light detection and ranging.
Yep.
Okay.
It's a laser-based long-range scanning technology.
So it's a lot like radar. It sends a beam down. Radar is a radio wave, and this is an actual laser that it drops down, bounces back, and is hyper accurate. So you can actually measure with LiDAR changes that are happening in the ground, so water table changes. You can actually measure tree growth too. So you actually see if you have overflights year after year after year, you can see how those trees are growing over time. Yeah, kind of expensive, but if it ever comes up in a meeting about the valley floor, having an overflight or two would be awesome. At least just looking at what's happening with the hydrology in the valley, because there are some unknowns with that. So we had a wide range of numbers with our estimates here. So to counter that, a lot of times we use a scale. So we actually have categories for different percentages. I'm just going to pass this around. I do need these back because I don't have a lot of data sheets left for...
Wait, you never said what your
bare ground. My bare ground.
Oh, bare ground.
My bare ground.
You said it often underestimated.
I was going to say less than 1%. I really don't see it.
There's actually not a lot of bare ground here. Our low numbers is where it actually really gets hard, when you're getting into that 5%, under 10% range.
Right.
And so I would say, somewhere less than 5%. And I can't venture any any less than that, because the difference between 1 and 3% is very, very different. Like that's hard to do. So instead of doing that, we have this is there's a lot of different cover scales out there. This is sort of a modified what's called Braun-Blanquet scale. So you have 6, 5, 4, 3, 2, 1 plus, and then R. So 6 in this scale is over 95% cover. So basically everything is covered by whatever species that is. 5 is 75 to 95%. 3 is 50 to 75. 2 is 25 to 50. I'm sorry, I got all up here. 5 is 75 to 95. 4. Not 3. There's a number in between 5 and 3. 4 is 50 to 75. 3 is 25 to 50. 2 is 5 to 25%. A lot of variability in that, and there's some, and we can discuss that a little bit.
Popular class.
And then 1 is less than 5%, but a lot of individuals. So, and then our plus, less than 5%, but just a couple of individuals. And R, less than 5%, but just a solitary.
Is that the scale we used?
Yep, it's the same one.
Same one you guys are using?
Yep.
Yep, pretty standard one.
With a midpoint for each. Do you do calculations with these on the data sheets to figure out the frequency and so on?
No, frequency is based off of frequency we're doing in this method as opposed to. So that actually covers Daubenmeier covers kind of both frequency and cover in the same frame. And so, all right, so we have a couple species here. We have our Juncus arcticus. We have Carex. Does anybody see any heads around?
Sedge?
Yeah, so it's our sedge. Yep.
Over there. But seed heads.
Seed heads. This is probably Carex aquatilus, just by feel of the blade. But because we can't positively ID it, it's Carex stuff.
What is this leafy?
Yeah, the little.
So we have, this is, I don't know if that's the basal rosette for that or not. Yeah, that's the basal rosette for our, for this. So this is the Laspi montanum, or it's
Mountain candy tuft.
Mountain candy tuft, very common understory species around. So it's a mustard. It's already flowered. This usually flowers, one of the first flowers of the year. So we have a few of those around.
And these are probably its leaves, but that's that tricky understory of non-flowering nonsense. That
so there is some interpolation, like, you start, if you do enough of these, you start picking up, like, looking at the basal rosettes as something that is flowering and isn't, like, you go to the next plot and say, well, okay, that's probably that origeron, because we have a lot of that around. Same shape, same texture, same feel to it, same appearance to it. You have to make some inference there. And so these are the basal rosettes for the mustard that we have growing in here.
That's these guys right here?
Like so these are the,
Okay. Oh, this?
Yep.
Just in kind of back of the envelope calculations, how much of this is native and how much is European or invasive?
This is all native.
It's all native.
This is the Laspi is a native species. Our Juncus is a very widespread species. I mean, this species of Juncus grows everywhere. Our mosses, I'm assuming, are native. I don't know very many invasive mosses. And then our Carex aquatilus is also a very common but widespread but native sedge species. So this is all,
Does that translate into some kind of valley floor health if it has a greater percentage of native, or is it more in terms of the uses, the projected uses?
And that's...
I know, that's a more political question, maybe.
That's something that, we're not necessarily looking for right now with this monitoring, but that can, because we do have sites that are, highly weedy, and so we have a lot of invasive species in there, and so those do show up in the metrics that we're using. And so it's then up to whomever to decide, all right, well, that's too many, or, and these methods aren't really designed to track weeds in particular. So we're developing another sort of protocol for the town to use to actually just map and figure out where populations of certain things are.
So more like clumps of invasive weeds or whatever. Yeah.
Which one of these is a rush? Because I'm not seeing any rushes in here because this is a sedge. I mean,
the sedges are these guys.
Sedges have edges.
And this,
They're sharpish.
and this could be just from doing a bunch of these. This in the habitat that we're in. This could be a regular grass.
Okay.
It's hard to tell without that clume, the actual the inflorescence of a sedge, which is what has the edges, the triangular body that grows the seed head on top of it.
Right.
So ultimately, over time, one will grow out of here maybe, and it'll flower and
brownish.
Yeah.
And so a grass is going to be completely flat, right?
Not necessarily. No. There are a lot of grasses. Actually, there are a number of our grass species. Actually, Bromus enormis, one of our introduced grass species, is fairly widespread out here. Has a blade that is fairly similar to this. There's some different nuances to it, but grass blades aren't necessarily all flat. Some have little W's, some have what we call keels, these little D-shaped things in it. Sedges do as well too.
Now, what's the difference between a grass blade and the sedge blade here then?
A grass has roots.
In a couple minutes, I can't really describe that. So
we're going to do vegetation identification with Amanda.
That's going to be a great question for Amanda.
Yeah.
So, and we're about to switch here, so let's
So you call this just simply a meter frame?
Yeah.
Instead of like the fancy
square meter.
Yeah.
Square meter thing.
That's what we used to use.
Yeah, it's a square meter.
I mean, it doesn't have a fancy name like double.
This is a frequency frame as far as, and I'm using, and that's just because it has a grid in it that I can do frequency with.
Right. Square meter would just be without that.
Exactly.
Frequency frame. Okay.
And I can use it also as my meter frame, my square meter, if I am doing just meter covers and stuff. So just really quick, our Juncus. Remember our categories are 6, over 95%, 5, 75 to 95%, 4, 50 to 75, 3, 25 to 50, 2, 5 to 25, 1 less than 5, but a lot of individuals, plus less than 5, but a couple of individuals, and R less than 5, but just 1.
Here, it's spelled out for you here, or you can pick a percentage and see which class it falls into.
Not what's dead.
We're just looking at live cover 2, yes. If it's dead, don't love it.
Thank you.
Yes. 50% looks like to me.
And one piece of advice is think about less than or greater than. Is it less than 50%? Is it more than 50%? Is it less than 25%? Is it more than 25%?
It's this way.
Okay, thank you.
So for our Juncus, what are you guys thinking? 2. I would give 2. Again, think about, especially when you have clumping it together. If I took all of my rush here and pushed it together, and again, it's one of those things, is it more than 25% or less than 25%? So probably less than 25%, more than 5% for sure, so it's in that 2 range. Our little Thalaspies.
Which ones are they? Yeah.
These are these guys. And again, it's not just the seeds that we're looking at, it's also the little basal rosettes on the ground.
So like these little leaves.
There's little tiny ones here.
Yeah, there are a lot of them in there.
Yeah. Yeah.
I'd say a 1.
One.
Less than, but lots of individuals.
Are we hired?
You guys are good. Great. I'm gonna go kick it in town. You guys.
Yeah, right.
Also, I'm still gonna bill my hours. You guys are.
That's gonna go fly fishing.
Yeah.
I don't know if you're
I do. I did not bring it in my rod with me, but
It would be too tempting, right?
I'm sure. Yeah, exactly. I'm sure I could find one in town somewhere. Yeah. So one, I would give this a 1 for my for the mustards here. Okay, so what else do we have? We have our carrots. I mean, we have a couple of those in here. So there's a clump there. There's a little clump. Actually, that might be it.
The what? Right here?
Yes.
These guys.
No, there's also one right here.
Yep, and these are going to be the same. Yeah, these are all the same. I'm just double checking that. So we have a clump here.
Those are sedges? Is that what?
These the sedges, yep. So carex and sedge are interchangeable.
Okay.
Juncus and rush are interchangeable.
How do you spell carex?
Carex.
This is our rush.
Yeah. Okay.
This is our.
It's so helpful to visualize, isn't it?
Yes, absolutely.
Less than, but lots of individuals.
And I did see one of the fungi down here, and so that's going to be a less than 1 R.
Yeah, if you have just one individual in there, that's going to be the R. I don't have any examples of a plus in here. If we just had a few less, maybe mustards in there, that might give it a plus. All right, so the last thing we have is our moss cover. And again, we're lumping all of our moss together. There's probably a couple different things growing in there.
For sure.
So even if the moss is covered by other stuff, doesn't it? It's only if it's completely exposed.
Open.
That's.
There's a little bit here.
We could. I don't have a protocol for that. Actually.
You can just extrapolate how you want.
So. Yeah, think about what moss is showing.
Okay.
What moss is showing. That's if I actually ran into a plot like this, that's how I would interpret the. So what moss do you see showing?
No, without grass or anything else growing in it, right? Moss alone, right?
Just whatever moss you see.
Whatever moss you see. Think of it as like bare ground. So if I have some like
under here.
litter covering it, then it's
still moss.
We already counted that as litter, though.
Right.
Does it have to equal 100%?
Nope.
No, because of the cover class.
These are cover classes, so we're actually not using the actual percentages. But if we were, and actually it does bring up a good point. If we're actually doing real percentages for a plot. For our cover, yes, you can have. There are methods that you can use that have covers that are greater than 100%.
Right.
Yeah.
That's where we got into some tricky stuff with bridal veil.
And then if I was really doing cover, I would have different canopy classes. So I would have like this cover class and a lower one and a lower one and this. So and I would actually break those up into different covers as well.
And rate them.
Yep.
So
I
can't decide if it's a 2 or a 3.
Can I see those numbers again? Yeah, I'd say 2.
I would too, since I tend to overestimate.
Yeah.
I decided a 2.
Cool. Yeah, I think I would also
unanimous.
About
About
30%.
Cool. Yeah, so you guys are definitely hired. Teach these guys over here all about this, and I'm gonna
The clumping is a really good way.
Yeah.
It took us a long time,
So
and it's really easy for the students in particular. That exercise of clumping, that was like a revelation.
And everyone's eye is a little bit different, and we all have kind of a different way of experiencing sort of spatial relations of things. Some people get it right away. I've got one of those minds that I kind of see in patterns. So like doing stuff like this is super easy for me, and it's kind of sometimes hard to convey to people. Some people are like, I don't know.
Do you ever have like 2 or 3 of you, and then like if you don't agree, you average it?
For this project, no, I have done that before.
But you have done it in like a bigger.
Yeah, and so if we're doing a more stringent like a study of something, then where we really need to have a good value.
Right.
And if there is some confusion, then that we would employ that type of thing.
And then with the high school students I'm working with, for we have the same student do the Daubenmeyers all the way through the whole plot, so it's consistent.
And that's actually something that we do, not necessarily with this, because we actually have different people doing on different plots.
Right.
And again, that's where our class is really, really handy.
Right.
Oftentimes, if you are like on a field crew doing, say, a forest inventory survey or something like that, you will have somebody they are the person that's doing canopy as they walk through.
Yeah.
They are the person that's looking at, or so they're keeping those tasks consistent. And again, that's always a debate within ecological fieldwork, is you do it one time, you come back out a year later, your eye could be different. The way you kind of look at things can be different. So, that's why we want to do a lot of plots. So you make up for those inconsistencies by doing a lot.
Well, and we want every student to be able to be trained in every job, so we do switch it up. But for one plot, one student for that task.
Yeah, exactly.
So,
I think that's a good way to do it.
So I wanted to point out that we have about 3 species here other than moss and fungus that we're looking at, and up in Bridal Veil it's very diverse, and our students were having 20 to 30 species in a square meter plot, and there's no way we could finish our 4 square meters in an hour and a half, even with 6 kids out there doing it. So it can get really tricky when you have a whole bunch of different species and different layers of canopy, which I wish we had thought about.
Can you talk about the Daubenmeyer real
And then, real quick, just for the visual clumping, I wanted to point out this is a Daubenmeyer frame. Daubenmeyer was a botanist with the Forest Service who invented this in like 1959 or so. But these are just color-coded, where this, if you use your imagination, this is 10%, this is a 10% square. This is a 1/10 of a square meter, first of all. So there's 10 of these in there.
This is a 20 centimeters by 50 centimeters is the dimensions of a Daubenmeyer.
So then to visualize 20% of the frame, it's this. It's 1/5 of this frame is color-coded here.
10%?
20%.
No, where's 20%?
10%.
No, it's divided into 5.
20% would be
5 stripes.
basically like these 2 lines here coming down for visualizing. This is 3%, so follow my pen, just this.
Just that little.
It just gives you, and then there's a 1%, I thought there was a 1% square.
Is it that little
3%.
white end, or?
We might have.
Flip it.
Did we,
So these come apart.
Oh, I think you put the wrong,
They come apart on purpose. You don't want to glue them, because if you have to go around a potentilla stem, which we often do, you have to encircle it. So you want them to come around, but
I think your 1% got,
I think my 1% is not on there.
Yeah.
Maybe I have 2 different Daubenmeyers put together here.
Let's see. Yeah,
there is normally a 1% is like
so
right
what you would
here.
see is...
Alessandra?
Yeah, that's
there
a
we go.
1%. This is... Yeah.
That's the 1%.
That's the 1% square.
Okay.
Okay.
No,
this is not 3%. They're all put together wrong. But that is 5%.
Yeah.
Yes.
Okay, I have to go home and do some Daubenmeyer puzzle pieces.
So if you were looking at, if this was put together right, you would have this little corner like here at 1%.
1%.
Yeah. So
and 5%.
Good student project.
Yeah.
It's a great clumping.
It's great for visualizing
Yeah.
what would fit into those.
And so we debated whether we would use Daubenmeyer on this plot. And so one way we could do that is go sequentially, along our axes, every so many meters or so, and actually put one down, put one down. Ideally, you do roughly, for something like this, we'd probably do about 50 of these within an area.
Whew.
Yeah.
It's a lot.
It goes really quick though. I mean, it's this
here.
Yeah, here.
Not at Bridalveil.
And so it's funny with diversity. Our most diverse plot, and I think we had. So one other thing we're doing aside from these 2 methods here, we're actually calculating richness on this site. So species richness. How many individual hits of different species do we have in our plot? And so by doing that, we just kind of do a little walkthrough to see what we have. A lot's recorded, but we do miss a lot. Like one of the things with this method I put this frame down right here, that's where it goes. Over here might be something totally different. So, and if we're thinking about weeds, I put the frame down, right there's an oxeye daisy. And so we might have oxeye daisy, doesn't show up in our frequency or our cover, but it would show up in our richness. So try to cover like all of our bases as far as like
show up in your richness.
And so richness is just a count of the different number of species you have in your area, whatever that area may be.
I wonder if there's any, I mean, another technology question, but like image recognition software that's being applied to photographs of meter squares, where you all five petal species show up, you know, kind of instantaneously or something like that.
So people are working on that. I know a few folks that are, you know, actually working on that as their thesis for a PhD. So that technology is getting there. One of the things I've worked on a little bit is actually taking images, looking down, and just documenting color changes.
Oh, okay.
So we can do that with, you know, off-the-shelf software of seeing, you know, how much blue we have in there, how much green we have in there.
Nice, okay.
And that'll be an indicator, if we're looking at, say, alpine plant phenology of where this was done, of seeing how, you know, I know that my blue species at this time are going to be probably these things.
Right.
And then we do some field, you know, we actually do all the counts, which is you go out every day and count every little thing in the 1 meter square.
And with students, when we do these, the students also photo, you know, just as a simple exercise, we had them photograph their plots. You know, each kind of square meter.
One of the things that we do with canopy, and it's the most accurate way of actually doing a canopy calculation, is you use a fisheye lens. You have your camera down at a certain height, pretty low. It takes an image up, and you just run it through image processing software. There's a lot of like ready-made programs out there to actually do just that, and it's just light or dark.
Okay. Yeah. Cool.
So,
interesting.
But I will say that, you know, probably within the next maybe couple of years, you will be able to take your smartphone, take a picture of a flower, and it will tell you what it is.
Right.
I'm a little bit ambivalent of that because I like the process of figuring out what it is on your own. But those tools will be available to us.
It just presumes you've got the curvature data in the data set already, so you're doing a matching. We did a project at ASU with Anasazi pots where we had certain curvature.
Oh, cool.
And you take a picture of a pot, and then it would recognize that curvature and pull up the possibilities of the match.
Exactly.
Yeah.
I mean, and I think with some of our flower species, and I can't imagine actually being a thing for like grasses. Or actually our sedge species, because there's some little minute things that you have to actually, like with a lot of our Carrick species, even IDing the field with a hand lens is almost impossible because there are little bits and pieces of it that you actually have to see under like some real magnification. So, you know, if that
interesting, really interesting.
All right, we better switch.
Cool.
Yes.
That was great, man.
Awesome,
Thank you so much.
Thank you.
Yes, thank
now,
you.
With the tape and the canopy, and
it's all wrong, and this one's blue.
And the trees, do you just measure, count, do you count the ducks, figure out canopy, or do you figure out where
what do you call it? It's not giving me a common name for it. Might be in that other book. Wherever it ended up. Hi.
Hey. We're doing our switch, but don't mind us.
Okay. Well, so we didn't quite get through everything, but I was going to show you some grasses. And what's really neat on this one, this is the just regular Timothy grass. You can see this is at what's called antithesis. So all the reproductive parts are out, and this grass is actively, like you can see the pollen sometimes, so it's not coming off right now. But this is kind of neat to see with your hand lens. You can see the anthers hanging out in the styles. If you guys want to check this out, means this grass is at the peak of its life right now.
What's an anther?
The anther is the male part that has the pollen on it, and that's the kind of pendulous thing that's hanging out there. Let me show you. I guess it's kind of a brownish, kind of purplish color. Brownish and purplish on that one.
What is the spelling of that second
sedge? Carrots.
Oh.
But I was really hoping to get a common name for that, but it wasn't
Oh,
listed.
there's a stick.
And what's this one that's right that we're stomping on?
So
here?
then finally this would be a rush, and if you guys touch this, it's very round. This is where we get rushes are round, and this is Juncus arcticus, so Arctic rush. And there are some exceptions, of course, with everything, but that mnemonic device of sedges have edges, the triangular stem, rushes are round, this nice round, smooth stem, and then grasses have joints. And you can see, you can see these joints where there's a little node, and where the blade kind of comes off from the culm.
And that's why bamboo's a grass.
Yes, bamboo is a grass. It's true.
And did you could you just, I mean, of course you've seen Arcticus before, but is it because of that open kind of panicle, the way it's hanging off of the, what's it called? What's this called? The
inflorescence here is coming off here.
Right.
Yeah, but we just found one yesterday that has a similar arrangement with Juncus effusus. It's kind of similar.
Although I thought if it's
What's this called here? Just the
I used to call it a stem.
C-O-M.
C-U-L-M.
Oh, comb. C-U-L-M.
No, I don't know. I mean, I like this one with the kids because it's color-coded here.
You probably want these bad.
Yeah, right.
Yeah, that's right. We kind of ripped them all apart, didn't we? This is called Trifolium repens.
Of course, that's the art teacher.
Repens is the white one. Pratons is the red one. Red or purple one.
Oh, yeah. I should have grabbed
And they're
one
nitrogen
too.
fixers.
They are nitrogen fixers, yep.
Yeah, in the pea family.
Most of our Fabaceae or pea family plants are nitrogen fixers.
That's why they use it as a cover crop.
Correct. Yep. And that's more than likely those wouldn't. So both Pratons and Repens are European species, and so they were probably brought over here for either forage. They're somewhat invasive, but we don't really consider them as necessarily a weed. But for cattle grazing, people put it out. So good forage for cattle, and it does fix nitrogen. So.
With the last group, we thought that it was a good idea to start with trying to use the dichotomous key to just kind of show people how to do it. And we first started off by talking about, and so now these have been sort of half dissected. So you're getting some slightly used plant material.
Recycling.
Yeah, we're recycling. But I just thought we'd start by talking a little bit about the characteristics of the sunflower family, and it's such a common family that we have here. So all of these, and somewhere there was a dandelion laying around. Does anybody see that? Oh, here, great. So all of these that look kind of similar but kind of different are members of the sunflower family. And
the clover.
Oh, not the clover. Sorry, that was just next to
Wow.
No. That's the pea family. So what's exciting about the sunflower family that I think people don't know until you really get in here with your hand lens is that when you're holding this in your hand, you're not holding one flower, you're holding many, many flowers. And what I mean by that, are you guys already familiar with that? Okay,
No.
Yeah,
cool.
people love learning this.
Yeah. So what's going on here is that we've got a platform called our receptacle. And all of these flowers are attached to the same receptacle. And if you pull this apart, you can pull out one flower. Let me see if I can pull out just one flower. Okay, well, I got two that time. So this is one flower. And you can see the parts, like this is the stigma sticking up. The flower has, a perfect flower has the male parts and the female parts. And what we have here is what's called a ray flower. And so this ray or ligule is just surrounding the male and female parts here. And then at the bottom here, there's some little bristles that are called the pappus. And I'm going to pass this around, and you can pull off one flower and take a look at it with your hand lens. And I'm going to pull this out.
Yes.
Colleen, you got to help me get a shot of this. This is great.
It's a really nice diagram to show you what's going on inside the head of a composite flower. So in this diagram, and we can kind of pass it around, that's explaining. So what we think of as the center of the daisy, those are called disc flowers. And what we think of as sort of the petals that like you would pull off and say, he loves me not, those are called the ray flowers. So the dandelion you're holding has only ray flowers and no disc flowers. And this little flower I'm going to pass around now, you can see the disc flower and the ray flower. They're similar.
What I'm holding was dandelion?
Yep, that's a ray flower. Or sometimes they call that ligulate flower, like a ligule. It's sort of like the... So the flower that you're holding here...
Dandelion is only disc, right?
No, it's only rays.
Only rays.
Right.
And this one is...
That's disc and rays.
Disc and ray.
So see, is that page still flipped to the right?
Because of the petal and the center?
These are the discs are the center. That's the ray flower coming off.
Okay. Past that.
And so this is ray only.
That's ray.
Okay.
So those are, so when you're using what's called a key, like, so it's fun to just go out with a book like the one that Laura has there and look at the pictures and idea, and sometimes you can do that, but sometimes you really need a systematic way to try to figure out what you've got in your hand. And a dichotomous key is set up such that it's dichotomous because you're given two paths. You can go down one or the other. It's like the choose your own adventure. And so as you keep coming to each fork in the key and you pick one path, you get closer to IDing your plant. In theory, it doesn't always work out that way because identifying plants can actually prove to be sort of hard. And with the last group, I had a lot of people who already knew how to use keys and had done it for a while. And so we tried to run through the key with this one. And these are, you'll see, kind of ripped apart because we had to, it's kind of a dirty business IDing a flower. You got to get in there and tear it apart and rip it up and yeah, can you just
and there's so much intricate vocabulary.
Yeah.
Oh my gosh.
Always going to the glossary.
Yeah. So if we take this
how hairy
flower,
it is.
And I'll kind of run through, I'm going to take this back for a second. And what we did with this one is we went through the key and kind of learned about each part of the flower and kind of some of the vocabulary. And we really took time to try to figure it out. I'm gonna kind of give you the answers on this one because it takes less time if we do it that way. So the first question it wants to know is the flower head composed entirely of ray flowers, or is it disc and ray flowers?
So RD.
Disc and
ray and disc. Yeah, we're looking at the purple one right now.
This one.
So Amanda, are you starting in that general aster family or sunflower?
So in one way we kind of cheated because we already knew what family to go to. We knew to start at Asteraceae, which is the sunflower family. And I mean this family is pretty unique because it is composed of many flowers, and we just know that general daisy is a sunflower family. So,
and are all asters also called composites?
Yes,
all composites asters. Because that's another term that people use.
Those are synonyms. So what happened was at some point in time, there was a big shift in the way they named plant families. They used to all end with Itae, like I-T-A-E, and so it was, I'm maybe not spelling that correct, but it was Compositae was the family, or was it Compositae? Now it's called Asteraceae. They all end in ACE. So there was a shift at some point, and that's happened a few times, like the brassicas, all the mustard families. That used to be Cruciferae, and now it's Brassicaceae. So that was one of the things that everyone had to kind of get used to. And actually, Plant names are changing all the time because we're getting more information about them as we study their DNA, and we have more advanced ways to find out about how plants are related to each other. And so we see them, like recently they took the lily family and decided that it wasn't really appropriate to have everything in the lily family, and they split it up and they put onions in their own family. So now there's the Alliaceae family, or I'm not really saying that correctly, but there's, you know, so we're seeing a lot of changes in the way they describe plants and the way they talk about plant taxonomy. But so starting with the sunflower family, we decided that we had rays and discs. So we get to skip ahead, bless you. We get to skip ahead down to here, and it asks us, they ask about our ray flowers. So looking at your ray flowers, are they white, blue, purple, or pink? Purple. Purple. Or are they yellow or orange? So since they're purple, it tells us go to key 4. So we're going to flip, we're going to skip ahead a little bit. Key 4. So the first question asks us, and you guys didn't get to see how this was growing, but you can sort of infer. The first question asks if it's a very low mat-forming perennial herb, or is it not mat-forming?
It's upright, non-mat.
Non-mat forming. Great. So we go to number 2. And this one, remember this picture of the receptacle, that this is like the platform that all of the plants are on? It's called the receptacle. So wait, I'm trying to flip back to that picture. So this platform that all the little tiny flowers are attached to, they want to know if it's densely bristly. And this is,
It's bristly.
so, but what's happening, and then the other thing that this picture showed us is that on each individual flower, they have something called the pappus. And so if, like, see if those bristles are actually attached to each flower like this, which is, or are they attached to the receptacle? To the receptacle.
No,
See, it came off with her flower. So they're actually attached to the flower. So the receptacle itself is not bristly. This is kind of the place where you really need that magnification, and you really have to get in there to know what's going on. And that was a hard couplet for us when we were working through this last time. So since I already did it, I know.
So the question was what?
Is the receptacle densely bristly?
Densely bristly.
So it's actually, yeah, so the receptacle is not bristly. So I get to go down to number 4 here, and now it's asking me about the pappus. So that's what you're seeing, and it wants to know if the pappus is capillary, which means like now that put us to our genus Erigeron, and what we could do then is work through the key of Erigeron to get us to the species. It's pretty long, so I'm just going to give you the answer. And it's Formosissimus, which is beautiful daisy.
Beautiful daisy.
And then they give us, we have a little description in here about it, and it tells us where it lives. Let me flip to the right page.
So the sunflower family is the biggest, isn't it, of all the flowers?
I think so, in our area.
Or just in general?
I think general, but definitely in our area.
Definitely in our area.
And then there's so many Erigerons too.
Yeah, and I mean, so all the fleabane daisies in Colorado, I mean, they take up this many pages of. Here's where it starts describing the species of Erigeron, and these are all different fleabane daisies. And it goes to the bottom.
And there's some very subtle choose your own adventure choices.
Yeah,
that are really hard to key out.
Yeah. So
then there wasn't a question in terms of the leaf structure, you know, whether they were alternating or.
No, but that's a good thing. A lot of times that will be a question if the leaves are arranged alternate or opposite. Because so if there was another leaf coming off right here at the same point as this one, that would be called opposite. This plant has alternate leaves. And another arrangement, if there were maybe 4 coming off at the same point, they would call that whorled.
Whorled. And aren't there some that have like a frond. I mean, like you have one stem and then...
Yeah, that's,
that's
called a
clasping.
compound leaf.
Compound.
And some are and some are even clasping.
Some are clasping, yeah. There's you find a whole new vocabulary when you start looking up plants, because you could have a leaf that is petiolate, which means it has like a little stem and then the leaf is there, or sessile, which I would call these ones. I would call these sessile to even maybe to clasping. They are sort of clasping at the base. You know, and sometimes you'll have leaves that are opposite that are fused and making kind of like a complete leaf around the whole stem.
Now,
So
what is this is yarrow?
Yeah, this is yarrow, and we can pass these around to you. You have one there, actually.
And this book has, it's your book, but on the inside covers there's all these different terms for different types of flowers or leaves.
I mean, otherwise this is alternating.
Ways that they describe.
This is one I tincture for immune.
Oh yeah?
Yarrow?
Yeah, immune and
Immune support?
yes.
Oh, that's great. So yarrow is used for immune support. Yeah, here is a nice little diagram to talk sort of about the leaf arrangement and the way they're attached.
Oh, yeah.
So if you look at this flower heads on this, what do you notice about this flower?
It's compound.
Yeah, it's also a composite flower. Just so this is, you're not looking at one flower here. When you pull this apart, you are actually, you've actually got discs and rays inside of here. Also.
And it's
arrangements.
If you pull that apart, you have discs and
terminal?
rays.
Say that again.
That's also a composite. Composite flower.
The leaf?
This one
here. The flower head is
a-
discs
is-
and
is
rays as well.
Yeah.
See here.
Umbel?
No, but it's a single flower, but it's kind of and so this is a compound umbel. See that?
Yes, I do. Yes, I see that.
So since we're talking about plants in the sunflower family, there's one I'd like to talk about that I don't have one here to show you, but I'm sure you've all seen oxeye daisy before.
Yes.
And so I just was going to mention as a quick story that in Durango, when you drive up 550 north to Silverton, for the past few summers, we've seen a little patch of oxeye daisy here and a little patch there and a little patch there. And this year we had a wet summer, and we have got oceans of oxeye daisy, where it just looks like snow is covering the ground almost. There's just
noticed
white.
a huge proliferation in Rico this weekend that I didn't know was there.
Yeah,
before.
and so here on the Telluride Valley floor, as I've been walking through here last week and this week, I see that you guys have a little patch here and a little patch there and a little patch there.
We used to have a lot more. They
been
worked
working
very
on it?
hard to get rid of it.
Yeah.
It actually has come back this
Yeah.
year a lot more than it has been in the last couple seasons.
Yeah.
Mountain Village has large areas.
Yeah, well, that's why it's here, is because it was in the grass seed in Mountain Village, and it's begun.
no.
Yeah, It was
It was in their meadow mix.
It was in their meadow mix.
Oh my God, you're kidding.
No.
So, yeah, I think that right now is a good opportunity, though. Like, it's still small enough to be able
Well, it's
to...
popped back.
Yeah.
It was even more. And I do know that Town Open Space was just out last week doing a site walk for invasives.
Oh, that's
Find
great.
patches of
Mountain
it
Village?
all
No,
along.
on the valley floor. Town Open Space. Town of Telluride Open Space.
And
The seeds get into the river, and you'll find patches of it all along the river, all the way down.
It's burst in Rico right now.
and
really?
when you pull it, when you pull it,
Yeah.
No,
Speaking
there's
Speaking
root
of invasives.
balls
Speaking
about
of invasives.
this about this big from the
Dandelions
the,
native, though,
oxeye
right?
daisies.
Well,
No, they're not.
Taraxacum officinale. There are native dandelions.
Eggs.
These are also an invasive species that can really get out of control.
This is the better nature.
And this
And
one is
people love them
tricky.
because they're so pretty.
They are so
they're like
pretty.
little snapdragons.
They are. And so it's funny, when I did my graduate research at NAU, there was a big infestation of a different species. It was Dalmatian toadflax.
Yes, I remember that.
Planaria dalmatica. Yeah, there was a fire near town, and it really got that area that was cleared out by the fire weeds like to fill in that open space. Like as soon as there's an opportunity, they'll fill that in. And so the Dalmatian toadflax really took off.
These little black bugs are friends? Are they eating this?
I'm not sure what those little bugs are.
There's one, it's a single flower.
Is it an aphid?
And when before it opens up, it's very cone shaped. And then when it opens, it looks kind of daisy-like, and it's yellow. And
the aphids usually aren't that dark.
I just wondered, I'm not describing it very well.
Can you do one of,
but
do you think it's a flower or an invasive?
Well, see, I've been told it's invasive.
Which one is that? Do you want to see if it's in this yellow section right there?
It's, Colleen, before the flower opens, it looks like an oval with a cone at the top. And it's yellow. When it opens, it's a single flower, and it pulls up really easily. But I don't know, that's pretty.
That didn't sound good.
Ooh, that didn't sound good at all. I'll look at the yellow flowers.
Right.
Here, let me see. I think it's in there. They're not looking at it.
Now, where's the girl?
This is the one weed I found in Bridalveil Basin on the trail up to Silver Lake. Just a small clump of these. I don't know how they're doing these days.
If it's a small clump, you should pull them. What's funny about these, so these will reproduce from the seed, but also through the root. So it's got a double strategy to spread.
Isn't that the same with the oxeye species?
Yes. Now,
Is that?
oxides are rhizomus.
And our valley floor daisy, from everything that I've heard and according to Ramona, is invasive. Yes. Although we love our daisy, I mean our dandelion. The valley floor dandelions are invasive.
And that's one of the biggest, like the most cover that we've been counting so far.
The native dandelion doesn't spread nearly as.
Oh, there is a native dandelion?
I don't know if you've been
I didn't know that.
How much plant stuff, but we were over above Silverton over years in past and came down the other gulch. I forget, it's the gulch that the Hard Rock 100 comes down, that stream over there. I can't remember the name of it.
Cunningham?
We did. I don't think it's Cunningham. Anyway, the dandelions were clear up into the high basin up there, which I was really surprised about. These kind of
I think anything that kind of wind seeds like that, like the dandelion, it's really fun to blow that. But when they can distribute that far and that wide, that's how they can really spread and really take off.
Yeah,
the cow poop probably helps too.
We do have dandelions in Bridalveil. I just kind of consider them.
Oh, it's the Tragon Pogon.
Yeah. Where are they not? I know.
Of the beach, maybe? Because it grows
which that's
that.
native.
Is that native? So that's not invasive?
Statigoceras? I'm not sure. This is Microceras. I am not sure. The other thing I was wondering if maybe you have is Tragopogon dubius, which is salsify. That might be.
We do have salsify in Mountain Village.
Yeah.
What that is.
It's not in here.
Is it a yellow flower?
Now, it's in this book it might be under blue because sometimes it's blue also.
Oh, okay. I know it's in this one, and I can grab it for you here. I'm not sure if it'll be in the pictures.
Laura, can you tell me the time?
Oh yes, it's 11:46.
Okay.
Oh, we have to.
I have to go.
Okay. Well, I was gonna one last thing let you look at clover, common clover. When you have your hand lens there and you can see much closer, I think everyone knows what a garden pea flower looks like. And if you look at these with your hand lens, you'll see that this little pom-pom is actually a collection of those little you have to use your imagination a little. And this is in the pea family. And I just thought that would be fun for you to see. And the description of these parts of the flower, this part at the top is called the banner. Then you can see it has two little wings on the side, and then the bottom lip is the keel. And so you can see that it's
So what are
You can tell when you look a little closer that that's in the pea
you know those
family.
little pea flowers.
Now
if you
I
look
have
at
a bunch
the
of
individual,
yellow clover
if
in
you look
my
at the
yard
individual
that
ones, you can see
is sort of
with this
taking
little bit of
over.
a stretch.
And I thought it was related
how they
to
look like those little
alfalfa.
sweet peas.
Yeah, it is.
Do you see it?
Is that a clover though?
Yeah.
Show me, Michael. What are you looking at?
So I think
I'm looking at keels and banners
which is they call that yellow
on
sweet clover
a
lot. And mellow lotus
white clover.
sativa
Through the
is
big one,
alfalfa.
you can
Well, this
big magnifier. Right.
well, this plant is nutritious and the flowers are edible.
Nitrogen fixer.
It is a nitrogen
Great.
fixer, so it is kind of a weed.
Yes.
I think it's
Now
not,
there's
it's listed on both sides
there's a
lot, so
clover
it's
out
pretty
there
easy.
with
What
the,
is it?
that
We're
has the
talking
yellow
about yellow
bulbs
sweet
on the top,
clover.
and that's
All of a sudden,
called
I have a
backyard
lot of
medic,
it in my yard.
and the backyard medic is the general tonic, and so if you're not
Probably
sure
because
which
it's been
plant to
wet
use,
here.
that's a good plant to get started with.
But that is
Nice.
a nitrogen fixer, so it's not quite as bad as
Great.
something that's
Thank you,
just
Michael.
displacing everything else and,
Right.
and kind of taking over. The last thing I kind of wanted to show you guys. Okay,
Yes.
you guys,
So
so
we
you're
learned
good to go.
learned the little.
We learned the little
Kinda,
rhyme,
sorta.
both his
Yes.
and Alessandra's.
The clean and
The clean and the dirty.
Oh, funny.
The dirty, you know the dirty version,
Which
right?
no, I guess I don't.
Alessandra has to tell it.
It rhymes with grasses.
Sedges have edges, rushes are brown, and grasses have asses. No, grasses have holes just like asses.
That is the third version of that poem I've heard.
Nodes all the way to the ground.
That's the clean version, yeah. And then Yvette said that grasses are hollow all the way to the ground. So there are some different takes on that one. But so just to look at, here's an example of sedges have edges.
That's it.
Oh, that's what Michael wanted to see.
Carex utriculata.
There you go, Michael.
That's called the beaked sedge.
Yes.
And what you're seeing there is you're seeing the female inflorescence here and the male inflorescence here.
Oh, on one stalk.
Yeah, on this one, for this
Which one's female?
this one that looks like a corn cob. Can you feel that triangular?
I can feel that. Yeah, and then but this would be a.
But see the thing up at the very
And this
top?
is the male part.
That's the male part.
Oh.
Wow.
So that's the male part on this one, right? Is
No,
this the male
This is
part?
the male part.
Male.
on the
Oh,
top.
and this too.
And this is the female.
And this is female.
Yeah. Right. So yeah, if you hopefully you got to see. And then this is the sedge. This is a grass here, and you can see this grass is fully at antithesis, and its pollen is out. Its anthers are out.
Did somebody else
But we shouldn't leave these toad flags here, should we?
Well, I just pictured them right over there.
Oh,
Guys, and they will get your questions to us. I'm Anthony at Mountain Studies, Amanda at Mountain Studies, Marcy at Mountain Studies, where Marcy went off to. .org. MountainStudies.org.
And just to kind of understand where all of this is going, the data is going, it harks back to our very first session, which some of you might not have been at, when Lance McDonald was out, just kind of giving us the overview of the valley floor. This is all going to the town of Telluride, in particular to Lance McDonald, who is a town of Telluride employee and is kind of overseeing all of this, and then he is the liaison between town council and town open space. So the next step would be for Lance to take anything that he sees pertinent, any like removal of some invasive species and how they'll do that. That goes to town open space, who maybe will come out and do a site walk or take a look, and then town open space would then make a recommendation to town council if it has to go to that level. So just to kind of understand where this is all going to. That's kind of the journey.
And so all the data that we're collecting with this sort of just one facet of the entire valley floor monitoring plan, we're actually developing a database for Lance and for the town, and I don't know if that's going to be publicly available or how that information, if you're interested in actually doing a study or something, how that's going to be accessible. But again, Lance McDonald is the person that will ultimately be sort of the keeper of that. And so we'll have water quality data, our vegetation data, our wildlife data. We're developing some protocols for the town to go out and document weeds. So walking, populations are actually, just GPSing where things are, just so they know. and so they can get a sense of spatially how things might be spreading. Because again, I do want to stress that what we're doing here is not looking at weeds specifically. If our weedy species happen to be within our plots, then they get documented. Otherwise, we are just documenting what vegetation we have at each of our plots. So.
And Telluride Institute is using all this information and background knowledge to create our high school college accredited program, which will be launched next summer, Valley Floor Living Classroom, which used to be Bridalveil Living Classroom. So transferring it down to here, where they will be collecting data that might feed into the whole town's database, and hopefully getting students involved in some of the more simplistic monitoring activities as citizen scientists, as well as perhaps adults.
And this is and I will speak just, putting a plug in for just science. This is a great vehicle for research questions. We have an awesome piece of property here. We have a piece of property that's been impacted by certain activities, and those are recovering in certain ways depending on the activity: grazing, mining, logging, rechannelization of rivers, you name it, changing of wildlife populations. So, if you guys are interested, or know people are interested in questions, now is the time to start thinking about those. Right. And as we're developing this sort of baseline data, how you guys compare, or whomever is going to be researching, compare off of that data and use that data. Because the one thing that as a researcher I hate to see data do is just sit.
Right. Which is what it was turning out with the Bridalveil program. These students were all doing amazing research projects, but it's just sitting on our website, really. So down here we want our students to do meaningful research projects. So in these summer programs, if any of you come up with good questions for our students to take on next summer, they each have to do their own college level research project. And it's so exciting to be moving it down to the valley floor, because there's this whole plethora of microhabitats and ongoing research and other things to tie into for the high school kids. So it's very exciting. It's much more accessible.
Yes.
They get college credit and high school credit. It's opened so many doors. Maddie Crowell just graduated from University of British Columbia with a botany degree. Skylar Hollenbeck, a Norwood kid. It's offered to Nucla, Norwood, and high school, Telluride high schools. Skylar Hollenbeck just graduated from the botany department at Fort Lewis College. So many. I mean, I would say 75% of the kids who do it end up pursuing science.
He never did.
And one of my really successful students who went to the School of Mines and got a degree in chemical engineering, she was super inspired by field science with Bridalveil Living Classroom, and she's just interviewing for a new job. She was working with Anheuser-Busch, and she's interviewing for a new job in Texas, and all these people want to talk about is Bridalveil Living Classroom. She says that's the #1 question she gets in all her job interviews.
Will you reintroduce Carl and how he's going to kind of take this?
So I'm graduating from being the founder and director of that program, and I'm passing the torch to Carl Topper, who has a wealth of experience. Oh, wonderful, thank you. A wealth of experience doing field-based research and teaching, and he's just a perfect fit. And then Vicki Phelps and Laura Kudo and I can help enhance and assist him, but he will be spearheading this whole transformation from Bridalveil Basin, above the waterfall, down to the valley floor.
And I would like to add the plug of this program will only be successful with community support. So, it's a very specialized program, and when I say that, I mean anywhere from volunteers to, we'll be doing some fundraising this fall. We have to fund it all through, local interest, and that's why we thought the valley floor would be a wonderful place. And I'm saying that also to spread the word to people that we do need help, whether it's volunteering, whether it's financial, spiritual, all of the above.
Up until now, the program has been offered free of charge, and it comes out to be about $3,000 to $4,000 per student with our budget. So it's been offered free of charge, and we hope to be able to continue that, but we'll see. It's been really valuable door opener for college acceptance and future career choices.